So let's start, guys. Welcome to the next lecture of MATH120. In the previous lecture, we discussed matrices and types of matrices.
Sir,
extremely sorry to bother you, लेकिन आपकी आवाज clearly नहीं आ रही. Can you please check your mic?
Can you listen me now, guys? Types of matrices. In the previous lecture, we discussed types of matrices and matrices.
सर आपकी आवाज ब्रेक कर रही है सर.
I think, can you listen me now properly? Is this fine now?
Yes, sir.
Yes, sir. अब सही है.
Oh, actually, when I go towards the board, I think this device basically is far from the laptop. Bluetooth issue, I think. I'll try to speak a bit louder.
सर आपका मेरे ख्याल में जो माइक्रोफोन की सेटिंग्स है वहाँ से सही डिवाइस सेलेक्ट नहीं हुई. इंटरनल माइक्रोफोन है, एक्सटर्नल माइक्रोफोन आप सेलेक्ट करें शायद तब सही होगा, क्योंकि अब दूर जाते हैं ना तो मेरा.
So we discussed type of matrices and matrix multiplication, some basic operations, matrix multiplication, and when it is permissible, when we can multiply two matrices and when we cannot, there is a criteria. Similarly, we can have matrix addition when two matrices are can be added. Two matrices can be added only if their orders are exactly identical and we add respective entries of each matrices and get the third matrix, which is the sum of the two matrices. I hope you know these things. Today, we are going to discuss inverse of a matrix. Inverse of a matrix. So its basic definition is inverse of a matrix is what? Let we have a matrix of order n cross n. Let A be n cross n matrix. Okay. N cross n square matrix, in fact. Only square matrices can have inverse. Okay, rectangular matrices cannot have inverses. Then another matrix B, then a matrix B of same order, in fact, then a matrix B of same order is called inverse of A if we have A into B, matrix multiplication, or B into A, their both product is identity matrix. This is identity matrix of order n, in fact. If A is any n cross n matrix, then another matrix B, we call it inverse of A if we can have these two things. You can write them separately. If we multiply A into B and B into A, both should be equal to identity matrix of the same order as of A and B. Then we write and in these two equalities in general, we can write them A into B is equal to B into A is equal to identity matrix of order n. Okay. Yes. Then we write that B is inverse of A. And also A is inverse of B. In fact, if any two matrices, they satisfy this property that when we multiply them, either from the right or from the left, then they satisfy this kind of identity, then both matrices are inverse of each other. In that case, either we write B is inverse of A or A is inverse of B. It's both same thing. I hope you get it. Now, let's have an example of this. For example, if you have any matrix A is equal to maybe 1 minus 2 and minus 3 and 4, this thing. How can you find the other matrices? For 2 cross 2 matrices, I hope you know how to find the inverse. Do you remember something? How to find the inverse of any 2 cross 2 matrix?
Transpose divided by the determinant.
The formula for finding of 2 cross 2 matrix, inverse of a 2 cross 2 matrix is what? 1 over determinant of A, 1 over determinant of A into adjoint of A. So this was basically the formula for finding inverse of a matrix in intermediate class, I think, in earlier classes. How to find the determinant of 2 cross 2 matrix? Determinant of A is what? You multiply the corresponding, the diagonal entries, 1 and 4, 1 into 4, negative of diagonal entries, negative 2, negative 3. Okay, this was the method of finding determinant of 2 cross 2 matrix. So it becomes 4, negative 6. So it becomes negative 2. So now the determinant is non-zero. So the matrix inverse can be calculated. If this determinant is 0, then you can see that the determinant is here in the denominator. If determinant is 0, we are unable to find the inverse of this matrix. So it's a basic criteria that determinant of that matrix should be not equal to 0 if you want to find the inverse of this matrix. Okay.
So, if determinant 0, so can we say that the inverse doesn't exist or it can't be found?
Yes, inverse doesn't exist. Inverse of this particular matrix does not exist. वहां पे भी basic definition में भी हमने ये कहा था कि आप यूं कह सकते हैं कि there exists a matrix B such that A into B or B into A is identity matrix. Okay. So now, what is the adjoint of a matrix? Adjoint of a matrix, or when you have 2 by 2 matrix, is nothing but you change the places of this main diagonal entries. You replace them here, and you change the sign of these two things. It is basically 3 and 2. This is what the adjoint of a 2 cross 2 matrix. Not this formula is not valid for 3 cross 3 matrix. Okay, you remember it. Now, what is the A inverse? A inverse is 1 over determinant, which is negative 2, and the adjoint of this matrix. This is the adjoint of matrix. Now you multiply this thing inside the denominator 1 over minus 2. So you get minus 2, you get minus 1, you get negative 3 by 2, and you get negative 1 by 2. Now this is what? This is your A inverse. Okay. Now you can check that this is your B matrix, for example, according to the definition we have written above. So now you can see that A into A inverse is what? You can multiply these two matrices. What is your A? 1, negative 2, negative 3, 4, and the product of this matrix with its inverse. Now you can see that the resulting matrix, after simplifying it, you get 1, 0, 0, 1, which is what? Which is identity matrix of order 2. Because the A is a matrix of order 2 cross 2. Similarly, you can prove that A inverse into A is again 1, 0, 0, 1. It's again identity 1, 0, 0, 1. So it is again I2. It means that A, either you multiply A inverse from the right or you multiply A inverse from the left. The answer in both cases is I2. Because you know that matrix they are not commutative. Means AB is not equal to BA. But in this case, this property is true. If we have two matrices which are inverse of each other, then their product is commutative. So remember this, that this commutative property holds for matrices which are inverse of each other. I hope you get it. Now, this formula works only for the 2 cross 2 matrices. There is another procedure of finding inverse of a 3 cross 3 matrix, which is basically you have to put in a lot of effort to find the inverse of a 3 cross 3 matrix. You find the cofactors and minors and cofactor expansions and many other things to find the inverse of a 3 cross 3 matrix. But when you have a matrix of order 5 cross 5, 10 cross 10, 50 cross 50, there is no or that procedure which we usually use, that finding cofactors. It's just basically a very lengthy procedure to find the inverse of any matrix. So we need to find some other way to find the matrix inverse of any matrix. So we are going to introduce now the row operations, elementary row operations, which we have discussed earlier, how to use elementary row operations to find the inverse of the inverse of any matrix. Okay, some important remarks about the inverse of a matrix is that not any square matrix have inverse. Not every square matrix has inverse. Okay, it's not necessary that every matrix has inverse. Only those matrices have inverses whose determinant is non-zero. But for the time being, we cannot check whether or how to find the determinant of a 3 cross 3 matrix or 10 by 10 cross 10 matrix, how to find the determinant of these kind of matrices. So we cannot use that property, whether the determinant of a matrix is 0 or not, we cannot check it. Second thing is inverse of a matrix is unique. If a matrix has inverse, then that inverse must be unique. It is not possible that a single matrix can have multiple inverse matrices. If inverse exists, then it must be unique. So let's discuss now how to find the inverse of a matrix when the order of a matrix is basically greater than 2 or 3 or 4 or 5 or 10 or anything. We need to find the inverse of this matrix. For example, 1, 2, 2, 3, 7, 9, minus 1, minus 4, negative 7. Okay. In order to find the inverse of this matrix, what do we write here? We write, or you consider this form. Consider this form. You write the matrix A here. 1, 2, 2, 3, 7, 9, negative 1, negative 4, negative 7. You draw a line here and then write an identity matrix of same order here. So this is your A matrix and this is your identity matrix of the same order. This is A3, this is I3. This is A matrix of 3 cross 3 order, and this is I matrix, identity matrix of 3 cross 3 order. Okay. Now you assume that this is a matrix, and you have to convert it, this matrix, into the left-hand side of this matrix. In fact, this A matrix, you have to convert this matrix into the reduced echelon form. Reduced echelon form. Okay. So you have to transform this matrix by using elementary row operations into reduced echelon form. The operations, the elementary row operations, which you apply in order to reduce this matrix into reduced echelon form, you apply same operations on this identity matrix as well. Okay. You apply same operations. In fact, when these operations will be automatically applied on this whole row. Okay. So in fact, you are going to reduce this A matrix into reduced echelon form. Okay. So here, first, what are the properties of reduced echelon form? You have to make 1 here. So fortunately, we have already 1 here. So the next step is you have to make zeros below this 1. So what you have to do here in order to make these two things 0. So you need to apply negative 3R1 plus R2, this one, then R2 is going to change, and the other one, what are you going to, R1 plus R2, sorry, R3, and this is going to change R3. One more thing which I want to tell you here, that at one step we can apply multiple elementary row operations, okay? But I don't recommend it that you apply multiple row operations. You just apply one operation on one step, because you'll have little chance to do a mistake if you apply only one operation at one step. So now apply these two operations on these two rows, completely these two rows, okay? Then tell me the rows. The first row will remain same, okay? The second row will be changed. You multiply this thing, this whole thing with -3 and add it to the here, okay? So you get 0 here, -3 से multiply करके add करें यहाँ पे, तो यहाँ पे you get 1, -3 से multiply करके add करें यहाँ पे you get 2, sorry 3, -3 से multiply करके यहाँ पे add करें you get -3, 1, 0, okay? Check it. If I'm wrong somewhere or not, you tell me please. So now you are going to add these two things, row 1 into row 3. You get 0 here, you get -2 here, you get -5 here, you get 1 here, you get 0 here, you get 1 here. So this is you have obtained here now. Now, what is the next step in the reduced echelon form? You try to make this the first non-zero entry in the second row. Here, you try to make it 1. So it is already 1. The next step is what? You have to make zeros below it and above it. Okay. So for that, what we do here, I'm going to apply, but you can use only this row, this pivot element, in order to make above and below zeros. So I'm going to do -2R2 plus R1, and this is going to change R1, and the other one is 2R2 plus R3. So this is going to change row 3. This is what we have obtained here. Now, let me write the resulting matrix somewhere, maybe here. I'm going to write it here. The resulting matrix will, I'm going to write it here. So this is the resulting matrix. The row 1 and row 3 are going to change. Row 2 will remain same. So I'm going to write row 2 before writing the row 1 and row 3. So here you get, now row 2 को 2 से multiply करें and add it to here, -2 से. You get here 1, you get 0 here. You multiply this with the -2, -6, plus 2, -4, -2 is plus 6 and add it here, 7, -2 and add it here, -2, -2 and add it here, you get this one, okay? Now the next row, the third row is going to change. You have to multiply second row by 2 and add it to here. So you get 0 here, you get 0 here, you multiply with this thing with 2, 6 and add it to -5, it is 1. And here you multiply this thing with 2 and add it to this, you get -5, multiply by 2 and add it here, multiply by 2 and add it here. So we get this one, okay? Now, what is the next thing in reduced echelon form? You go to the third row and try to make this entry 1, which is already 1, fortunately. So what is the next requirement? You have to make these above entries 0. Okay, now we need to apply 2 more operations here to make those entries above that pivot entry 0. So what operations do we need here? I'm going to multiply 4 with R3 and add it to R1. So row 1 is going to change here, and then -3R3 plus R2. in order to make this entry 0. And this is going to change row 2. Okay. I hope you are getting my points. If you have any question, you can ask me. There are questions in the chat window. No, there are no questions. If you have any questions, you can ask me. Now, we are again going to make these two entries 0. So we are going to multiply this one with the 4. Let's write the third row, because the third row is not going to change. This one, -2, -5, -1, -2, -1. So this one. Row 1 is going to change, and what would happen here? 1, 0, 0, 1, 0, 0, because you multiply this thing with the 4 and add it to here. You multiply with 4 and add it to 7. 4 5s are 20 and 7 -13. 4 2s are 8 and add it here 6. Yes, 4 and add it here 4. Now the second row, what you are going to do, -3 से multiply करें third row को and add it here. -3 से multiply करें, you get 0 1 0. Yes, -3 से multiply करें और add करें 15 12. ये -3 से -6 आ जाएगा. Add it to 1, -5, and -3. Add it to here, -3. So this is what you have obtained finally. Now, can you tell me whether this matrix is in reduced echelon form or not?
It is.
Yes.
It is in reduced echelon form. Okay. If after reducing the original matrix here, if we obtained, after reducing it into a reduced echelon form, if we obtain I3 here, okay, basically we are going to convert this matrix into identity matrix. Whereas the same operations on the identity matrix will convert the identity matrix into inverse of that matrix. So this matrix, which was identity matrix, now have been converted into the inverse of that original matrix.
सर एक सवाल है.
जी बेटा.
शायद आप ये आगे कवर करने वाले हैं, सॉरी अगर वो करने वाले हैं.
No
मगर यही
problem.
था कि बेसिकली आइडेंटिटी मैट्रिक्स हो सकता है ना भी हो ना, यानी कि पहले अगर
हाँ.
0 हो और 0 1 करके.
अगर यहाँ पे 0 आ जाता है, for example. So this is not an identity matrix of order 3.
जी.
And also, this is not the inverse of A. Okay? It means A inverse does not exist.
सही
Okay?
सर.
But that's simple. But still, because it is identity matrix, so this is A inverse. I hope you get it. So this is your A inverse now. You can say that, therefore, A inverse is what? A inverse is this matrix, -13, 6, 4, 12, -5, -3, -5, 2, 1. You can check it. How can you check whether this A inverse is correct or not? You just multiply, you just check this property, this one. You just multiply A into A inverse and A inverse into A. In both cases, you must get identity of order 3 in this example. Okay, you can multiply two matrices. You multiply these two matrices A and A inverse, they should be their product should be identity matrix. This is how we can check whether the inverse which you have found is correct or not. So some people are waiting to be accepted. I have accepted all of them. If you have any question, you can ask me. This is how we can find the inverse of a matrix without using that formula or without using that procedure, which you already might have studied in your intermediate classes or FSC A levels. We will discuss that method as well, so that you can revise those things. जी बेटा.
सर आपने कहा था आपको हम रिमाइंड करवा दें if the time is near 4:30, 4:35 हो गए हैं. You have to inform us about the quiz.
Okay, the quiz will start at 4:45. Don't worry about it. So this is all about inverse of a matrix. If you have any question, you can ask me.
उसका पैटर्न क्या होगा?
इसका पैटर्न क्या होगा? 2-3 सवाल होंगे यार, आपने करने होंगे, हल करने होंगे. I'll tell you. Don't worry. Give me 1 minute. If you have any question regarding the inverse of a matrix, you can ask me. I told you if this matrix, the original matrix, this matrix has not been converted into identity matrix after using row operations, then the other matrix will not be inverse of the original matrix. This must be identity matrix of the same order. Okay, either you get 0 here or you get somewhere 0 here. So this is not identity matrix exactly. So this is again not an inverse of a matrix. So this matrix must be identity matrix in order to get the inverse of the given matrix. Now, whatever the order of that matrix is, for example, this matrix is 4 cross 4, 10 cross 10, whatever the order of this matrix is, you can follow this procedure in order to get the A inverse. Okay. If you have any question, you can ask me. Now try to find the inverse of this matrix. I'm giving you another example in which the given matrix will not be converted into an identity matrix. Okay. Here is the other example. Find the inverse of this matrix. Find A inverse if A is what? A is 3, 2, 5, 4, 4, 8, -2, 2, 0. So this is the matrix whose inverse you have to find. So what we do, we try to write A, 3, 2, 5, 4, 4, 8, -2, 2, 0, line, and the same order identity matrix. Okay. You try to convert this matrix into identity matrix of order 3, apply the same operations, row operations, on this matrix, and this matrix will be converted into A inverse if it exists. Okay. If this matrix has not been converted into I3, then this will not be the inverse. Try it yourself. I hope you can do it. If you have any question, you can ask me. So I'm going to stop today here because you guys have a quiz. Now we are going to discuss the quizzes. If you have any question, you can ask me regarding to today's lecture. If not, I'm going to stop the recording.